Right now, as you sit there doing nothing at all, you are being pushed, pulled, held together, and kept from falling through your chair by something you cannot see, cannot smell, cannot taste, and yet it is everywhere. It fills every inch of the room. It fills every inch of the universe. And here is the funny part. You are made of it. Your thoughts are running on it. The light reaching your eyes is a ripple in it. What is this thing? It has no weight you can put on a scale, no color, no sound. And yet without it, there would be no atoms, no molecules, no you, no me, no stars, no anything. It is the electromagnetic field. And I want to spend some time with you today getting to know this invisible web you have been living inside your whole life without ever realizing it. By the end of our time together, you will understand what the electromagnetic field actually is, how it holds matter together, how it carries light across the emptiness of space, and why it is no exaggeration to say that nearly everything you have ever touched, seen, or experienced is electromagnetism in disguise. That is the promise. Now let us earn it. Let me start with something you know. You have held a magnet. Maybe as a child you played with two magnets and felt that strange thing happen when you bring them close. You do not have to touch them together. They feel each other. There is a push or a pull through the air, through nothing at all, and it acts at a distance. That is spooky, is it not? Newton thought so. He called it action at a distance, and he did not like it one bit. How can one thing push another without touching it? How does the magnet know the other one is there? Now, here is where it gets interesting. You have also rubbed a balloon on your hair and stuck it to the wall, or shuffled across a carpet in your socks and zapped your friend. That is electricity, static electricity, a different word, a different feeling, and yet, and this took centuries to figure out, it is the same thing. Magnetism and electricity are two faces of the same phenomenon. They are not separate. They are married. They are inseparable. And the thing that unites them is this field, this invisible presence that fills all of space. So what is a field? Let me give you an analogy. Imagine you are standing in a swimming pool. The water is calm. You are standing still. Now somewhere across the pool, someone jumps in. You feel it. Not right away. There is a delay. A ripple travels across the water and pushes against you. Now, here is the important thing. The person who jumped did not touch you. The water touched you. The water carried the influence from there to here. The water is the medium. The water is the field. Now take away the water. Take away everything. Leave only empty space. And here is the miracle. Something is still there. The electromagnetic field is still there. It is not made of atoms. It is not made of anything you can scoop up in a bucket, but it is real. It carries energy. It carries momentum. It can push on things. And when something happens over here, a ripple can travel through this field and affect something over there. That ripple, when it is the right kind, we call light. Let me try another analogy. Think of a spider web, a real spider web, strung between branches, glistening with dew. The spider sits in the center, waiting. When a fly lands on the web, the spider does not see the fly, not right away. What happens? The fly causes a vibration. That vibration travels along the strands of the web. The spider feels the vibration. The spider knows something is there, even without looking. The web is the field. The vibration is the message. Now stretch that web out to infinity. Make it fill all of space, in every direction, with every point connected to every other point. That is a rough picture of the electromagnetic field. Except it is not made of silk. It is made of, well, we do not know what it is made of. It just is. It is one of the fundamental ingredients of reality. Let me pause here and do what I call the Feynman Check. Let us make sure a bright 12-year-old could follow this. Here is what we have said so far. There is an invisible something that fills all of space. We call it the electromagnetic field. When you have an electric charge, like an electron, it disturbs this field, the way a pebble disturbs a pond. That disturbance can reach out and push or pull on other charges. That is how magnets work. That is how electricity works. And when the disturbance travels as a wave, that is light. Simple, right? Good. Let us keep going. Now, I want to tackle a misconception, a very common one. People think that electricity and magnetism are two different forces that happen to be related, like cousins at a family reunion. Friendly, sure, but separate people. That is wrong, dead wrong. They are the same force seen from different angles. Let me show you what I mean. Suppose you have a wire with an electric current flowing through it. Just electrons drifting along. Now put a compass next to the wire. The needle moves, it points in a new direction. The current creates a magnetic field around the wire. Everyone learns this in school. But here is the deep question. Why? Why should moving charges create magnetism? Now let us look at it from another angle. Suppose you have a magnet, sitting still, doing nothing. No magnetic field from current, just a permanent magnet. Now you run past it, you move. From your point of view, the magnet is moving past you. And guess what happens? You see an electric field. The moving magnet creates electricity. Just by moving. The same magnet, the same situation, but seen from a different frame of motion, you get a different mix of electricity and magnetism. This is what Einstein figured out. It was one of the clues that led him to special relativity. Electricity and magnetism are not two things. They are one thing viewed from different perspectives. When you change your state of motion, what looked like pure electricity becomes a mixture of electricity and magnetism. What looked like pure magnetism becomes a mixture. They transform into each other. They are two components of a single entity we call the electromagnetic field. Let me tell you the story a little more carefully, because it is fascinating. Einstein, as a young man, liked to imagine thought experiments. And one thought experiment particularly troubled him. He imagined chasing a beam of light, running alongside it, getting closer and closer to its speed. What would happen if you caught up to it? According to common sense, if you run alongside a wave, the wave appears to slow down. If you could run at the speed of the wave would appear to stand still. You would see a frozen ripple, not moving at all. But Maxwell's equations said something different. The speed of light appears in those equations as a constant. It does not depend on how fast you are moving. The equations say that light should always move at about 300,000 kilometers per second, regardless of your motion. That seemed impossible. That seemed like a contradiction. Einstein resolved this by taking Maxwell's equations seriously. If the speed of light is the same for everyone, he reasoned, then something else has to give. What gives is your intuition about time and space. Time passes at different rates for observers in relative motion. Lengths contract. The simple rules of addition for velocities no longer apply at high speeds. This is special relativity. And here is the connection to what we were saying before. In relativity, electric and magnetic fields transform into each other depending on your state of motion. A purely electric field in one frame becomes partly magnetic in another frame. The unification of electricity and magnetism is not just a mathematical convenience. It is a deep truth about space-time. The electromagnetic field is a single object living in four-dimensional space-time. And what you call electricity and what you call magnetism depends on how you slice that space-time with your motion. This is deep. This is beautiful. And this is one of those places where nature shows you that your intuitions, built up from everyday life at everyday speeds, are not adequate to the truth. You have to let the mathematics, let the experiments, teach you something new. Now let us go deeper. I promised you a thought experiment. Here it is. Ready? Imagine you are holding a single electron, just one lonely electron in empty space. It has an electric charge. That charge creates an electric field around it, spreading out in all directions like the quills on a porcupine, pointing radially outward. Fine. Now shake the electron. Move it up and down, back and forth. What happens? The field has to adjust. The field lines have to change their positions to match the new location of the electron. But here's the thing, that adjustment cannot happen instantaneously. Nothing can travel faster than light, not even information about where the electron is. so the adjustment travels outward at the speed of light. There is a kink in the field lines, a ripple, a wave. Now let me slow down and really paint this picture for you, because I think most people miss what is happening here. Imagine the electron sitting still. The electric field spreads out from it like the spokes of a wheel, going in all directions, getting weaker with distance but never quite reaching zero. Every point in space knows about that electron. The field is there, waiting. Now you give the electron a little push, a jiggle. For just a moment, it moves to the left and then back. What happens at a point far away? Well, for a while, nothing. The news has not arrived yet. The field at that distant point is still oriented as if the electron had never moved. But then the news arrives, traveling at the speed of light, and the field has to adjust. It has to swing around to point in the new direction. But wait, the electron has already moved back. So another piece of news is on its way. The field at that distant point ends up swinging back and forth, oscillating, dancing in response to what happened at the source some time ago. That oscillation, that sympathetic dance of the field, is electromagnetic radiation. It is light. It is radio. It is the whole electromagnetic spectrum. And here is the profound part. Once that ripple leaves the electron, it is on its own. It does not need the electron anymore. The wave propagates through space, self-sustaining, the electric field creating the magnetic field, creating the electric field, forever outward, until it hits something. This is how the sun can warm your face from 93 million miles away. A long time ago, electrons in the sun jiggled. Those jiggles became waves. Those waves traveled for 8 minutes through the vacuum of space, needing nothing, touching nothing, and then arrived at Earth and shook the electrons in your skin. Your skin warmed up. Information, energy, crossed the void, carried by the field. That is not magic. That is electromagnetism. That wave carries energy. It carries momentum. If it reaches another electron far away, that electron will feel it. It will start to shake too. You have transmitted a message, transmitted energy, from one place to another through empty space. That wave is light. Think about that for a moment. Light is not some separate thing that nature invented for seeing. Light is what happens when you shake an electron. Light is a ripple in the electromagnetic field. The same field that makes magnets stick to refrigerators is the field that brings you the light of distant stars. It is the same stuff. Now, you might ask, wait a minute. If I shake an electron and it makes light, why do I not see light coming off everything that moves? Well, you do. Everything that has electric charge and accelerates emits electromagnetic radiation. If you shake an electron gently, you get radio waves, long, lazy ripples. Shake it faster, you get microwaves. Faster still, infrared. Even faster, visible light. Faster than that, ultraviolet, X-rays, gamma rays. All the same phenomenon, all ripples in the electromagnetic field. The only difference is how fast you shake. Let me paint this picture more carefully, because it is beautiful. Imagine a piano keyboard. On the left, the low notes. On the right, the high notes. Now, stretch that keyboard until it spans hundreds of octaves. The leftmost keys, if you could hear them, would be radio waves, long wavelengths, low frequencies. Billions of oscillations per second, which sounds like a lot. But for electromagnetic waves, that is slow. Move up the keyboard. The wavelengths get shorter. The frequencies get higher. You pass through microwaves, the kind that heat your food. Then infrared, the warmth you feel from a fire. Then, in one tiny octave out of the hundreds, visible light, red, orange, yellow, green, blue, violet. The whole rainbow that you can see with your eyes is just one octave of this enormous keyboard. Keep going higher. Ultraviolet, the light that gives you sunburn. Your eyes cannot see it, but your skin can feel its effects. Higher still, X-rays, the kind that pass through your flesh but not your bones, letting doctors see inside you. Even higher, gamma rays, the radiation from nuclear reactions and cosmic explosions. All of this, from the longest radio wave to the shortest gamma ray, is the same phenomenon. All of it is ripples in the electromagnetic field. The only thing that changes is the frequency, how fast the field oscillates. Your eye happens to be sensitive to a tiny slice of this spectrum. A radio antenna is sensitive to another slice, an X-ray detector to another. But the field does not know the difference. It is all the same to the field. And here is something remarkable. There is no obvious reason why this spectrum should stop. There could be waves of any frequency, in principle, longer than any radio wave we have detected, shorter than any gamma ray. The electromagnetic field does not run out. It is continuous. It is one of the great unifying features of nature. Your radio antenna works exactly this way. Electrons in the antenna are made to shake back and forth millions or billions of times per second. That shaking sends ripples through the electromagnetic field. Those ripples spread out at the speed of light. When they reach your car radio, they make electrons in that antenna shake. That shaking is converted into sound. You are listening to electromagnetic ripples that someone created hundreds of miles away. Magic. Except it is not magic. It is physics. Let me tell you about Heinrich Hertz. He was a German physicist working in the 1880s. Maxwell had predicted electromagnetic waves, but no one had ever detected them deliberately. Hertz built a device that could create electromagnetic waves and another device that could detect them across the room. He measured their speed. He showed they could be reflected, refracted, and polarized, just like light. He proved that Maxwell was right. When asked what use these electromagnetic waves might have, Hertz reportedly said that he did not see any practical applications. They were just an interesting physical phenomenon that confirmed Maxwell's theory. Within decades, of course, radio was invented. Television, radar, the entire wireless communication revolution. Hertz was a great physicist, but not, perhaps, a great prophet of technology. Now let me tell you something even more remarkable. And this gets us closer to the heart of matter itself. Atoms are made of electrons and nuclei. The nucleus is positive, the electrons are negative. Why do they stick together? Why do they not fly apart or collapse into each other? The answer has to do with the electromagnetic field, combined with quantum mechanics. But even before quantum mechanics, the basic attraction is electromagnetic. Here is a puzzle that bothered the physicists of the 19th century. If an electron orbits a nucleus, like a planet orbits the sun, it should be constantly accelerating. Remember, changing direction is acceleration, even if your speed stays the same. And we just said that accelerating charges radiate electromagnetic waves. They lose energy, so the electron should spiral inward, radiating energy as it goes, and crash into the nucleus in a tiny fraction of a second. Atoms should not exist. Obviously, atoms do exist. You exist. So something was wrong with the classical picture. This was one of the clues that led to quantum mechanics. The electron does not orbit in the classical sense. It exists in a quantum state, a probability cloud, and the rules of quantum mechanics prevent it from spiraling in. But that is another lecture. The point here is that the electromagnetic force is what is trying to pull the electron in, and it is quantum mechanics that stabilizes the situation. When you sit on a chair, why do you not fall through it? The atoms of your body are mostly empty space. The atoms of the chair are mostly empty space. If you could shrink down and look at an atom, you would see a tiny nucleus, incredibly small, surrounded by an electron cloud that is, comparatively speaking, enormous. The nucleus is like a fly in the middle of a cathedral. Most of the atom is emptiness. So why does empty space not pass through empty space? Let me tell you what happens at the microscopic level. When the electron clouds of your atoms get close to the electron clouds of the chair atoms, they overlap. Electrons are fermions, and there is a rule in quantum mechanics called the Pauli exclusion principle that says two fermions cannot be in the same quantum state. This creates a kind of pressure, a resistance to compression. But behind it all, the force that is pushing back is electromagnetic. The negative electron clouds repel each other. They do not want to overlap. They push back through the electromagnetic field. And here is the thing. The atoms never actually touch. Not in the classical sense, not like two billiard balls clicking together. What touches is the field. The electromagnetic fields of the atoms interact, and that interaction gives you the sensation of solidity. Every surface you have ever touched, every texture you have ever felt, was your electron clouds interacting with other electron clouds through the electromagnetic field. It is all electromagnetism, all the way down. Let me give you another example. Friction. When you walk across the floor, what keeps you from slipping? Friction. But what is friction? It is the electromagnetic interaction between the atoms of your shoe and the atoms of the floor. The surfaces are rough at the microscopic level, full of peaks and valleys, and the electron clouds of those peaks interact with each other. They push and pull. They catch on each other. That is friction. It is not some separate force. It is electromagnetism at work. Or consider the chemical bond. Why does water have the formula H2O? Why not H3O or HO? The answer is electrons. The way they arrange themselves, the way they are shared between atoms, the way the electromagnetic forces balance out, chemistry is applied electromagnetism. Every molecule, every crystal, every protein in your body is held together by electromagnetic forces. When you pick up a cup of coffee, the atoms in your fingers do not touch the atoms in the cup. Their electron clouds repel each other. The electromagnetic field transmits the force. You feel the cup through the intermediary of the field. Every touch you have ever felt is electromagnetism. Every push, every pull, every hug. Electromagnetism. Let me dwell on this a moment longer, because I do not think most people really appreciate it. When you hold hands with someone you love, what is happening physically? The electrons in your skin are repelling the electrons in their skin. Your atoms never come close to touching. What you feel is the force transmitted by the electromagnetic field. That feeling of warmth, of connection, is electromagnetic. The tenderness, the sensation of contact, it is all the field. This is not meant to diminish the experience. It is meant to enhance it. You are connected to the person you love through the same force that lights the stars and powers the sun. The same equations that describe lightning describe the touch of a hand. There is no distinction at the physical level between the romantic and the cosmic. It is all electromagnetism. And think about your own body. Your nervous system runs on electricity. When you have a thought, it is because millions of neurons are firing, sending electrical signals down their axons, releasing chemicals at synapses, generating more electrical signals in the next neurons. Your brain is an electrical machine. The process that gives rise to your conscious experience is electromagnetic. Your thoughts, your memories, your dreams, all are patterns of electrical activity in the neurons of your brain. When you read these words, light enters your eyes, triggers electrical signals in your retina, and those signals propagate to your visual cortex, where they are processed by more electrical activity. The entire experience of seeing is electromagnetic from start to finish. The chemical bonds that hold molecules together, electromagnetic. The reason water is wet, electromagnetic. The reason steel is strong, electromagnetic. The reason you can see, the reason light enters your eye and gets detected by your retina, electromagnetic, obviously. The reason your nerve cells can fire signals to your brain, electromagnetic. The reason your muscles contract, electromagnetic. Your muscles work by proteins called actin and myosin sliding past each other. What makes them slide? Electrical forces. What holds the proteins in their shapes? Electrical forces. What releases the calcium ions that trigger contraction? Electrical signals from your motor neurons. It is electricity all the way down. Every movement you make, every breath you take, is powered by electromagnetism. When you think about it this way, you realize that almost everything you experience in daily life is electromagnetic. The exceptions are gravity, which keeps your feet on the ground and the moon in orbit, and the nuclear forces, which hold the nucleus together and power the sun. But those nuclear forces only matter in the tiny domain of the nucleus. Gravity is incredibly weak at the scale of atoms. Electromagnetism rules the world of everyday experience. Now I want to talk a little bit about the mathematics, but I will keep it gentle. The equations that describe all of electromagnetism were written down by James Clerk Maxwell in the 1860s. 4 equations. Just 4. And from those 4 equations, you can derive everything. The behavior of magnets, the sparks from your fingers, radio waves, light, X-rays, everything. Let me give you the flavor without the symbols. The first equation says, electric charges create electric fields. The field lines start on positive charges and end on negative charges, or go off to infinity. The second equation says, there are no magnetic charges, no magnetic monopoles. You cannot have a north pole without a south pole. Magnetic field lines always form closed loops. They do not start or stop anywhere. The third equation says, a changing magnetic field creates an electric field. This is Faraday's discovery. This is how electric generators work. Spin a magnet near a wire and you get a current. Now, let me tell you about Faraday, because his story is remarkable and his discoveries are at the heart of everything we are discussing. Michael Faraday was a bookbinder's apprentice in London. He had almost no formal education, he could not do advanced mathematics, but he had something more important. He could see things in his mind, he could visualize, and he invented the idea of the field. Before Faraday, people thought about electricity and magnetism in terms of forces acting across empty space. One charge pulls on another charge. One magnet pulls on another magnet. Instant, direct, through nothing. Faraday did not like this. It did not feel right to him. He imagined instead that a magnet sends something out into space, filling the space around it, and that other magnets feel this something. He called them lines of force. If you have ever seen iron filings sprinkled around a magnet, arranging themselves into beautiful curving patterns, you have seen what Faraday was imagining. Those patterns are the field made visible. Faraday discovered electromagnetic induction in 1831. Here is what he did. He wrapped a coil of wire around an iron ring. On the other side of the ring, he wrapped another coil. The 2 coils were not connected. There was no electrical contact between them. Then he connected the first coil to a battery. What happened? At the moment he connected the battery, just for an instant, a current flowed in the second coil. When he disconnected the battery, another brief current in the opposite direction, but in between, when the current in the first coil was steady, nothing happened in the second coil. Think about this carefully. No current flowing steadily, but when things change, when the current is growing or shrinking, the other coil responds. What does this tell us? It tells us that a changing magnetic field creates an electric field. The growing current in the first coil creates a growing magnetic field. That growing magnetic field creates an electric field in the second coil. The electric field pushes the electrons. Current flows. But once the magnetic field stops changing, the electric field disappears. The current stops. This is the principle behind every electric generator ever built. Spin a magnet near a coil of wire. The magnetic field through the coil is constantly changing, first one direction, then the other. That changing field creates an electric field. Current flows. You have converted mechanical motion into electricity. Every power plant, every windmill, every hydroelectric dam works on this principle that Faraday discovered in his laboratory almost 200 years ago. The fourth equation says electric currents create magnetic fields, and so do changing electric fields. This second part, the changing electric field, was Maxwell's own addition. It was his great insight. And it is this term that allows electromagnetic waves to exist. Let me explain why this was so important and why Maxwell deserves to be ranked with Newton and Einstein in the history of physics. Faraday discovered that changing magnetic fields create electric fields. Fine. But what about the reverse? Does a changing electric field create a magnetic field? The experiments at the time did not clearly show this. But Maxwell, working with the mathematics, realized something was wrong. The equations did not balance. They were not self-consistent. Something was missing. He added a term. A changing electric field, he said, acts like a current. It creates a magnetic field just as a real current would. He called this the displacement current. And when he added this term, the equations clicked into place. They became beautiful, they became symmetric, and they predicted something astonishing. Maxwell sat down and combined his equations, manipulating them mathematically, and out popped a wave equation. The equations predicted that disturbances in the electric and magnetic fields would propagate through space as waves. And when he calculated the speed of these waves from the known properties of electricity and magnetism, he got a number, roughly 300,000 kilometers per second. That number was already known. It was the speed of light, measured by astronomers looking at the moons of Jupiter. Do you see what happened? Maxwell did not set out to explain light. He was just tidying up the equations of electricity and magnetism. But when he finished, light fell out. Light was an electromagnetic wave. The same equations that described how magnets attract and batteries push also described how light travels through space. This was one of the greatest unifications in the history of science. Maxwell wrote, and I am paraphrasing here, that the agreement of the results seems to show that light itself is an electromagnetic disturbance in the form of waves propagated according to the laws of electromagnetism. He was not sure, you see. He was being cautious. But he was right, and every experiment since has confirmed it. Here's how it works. Suppose you have a changing electric field. According to Maxwell's equations, that creates a magnetic field. But now you have a changing magnetic field, which creates an electric field, which creates a magnetic field, which creates an electric field. The two fields keep regenerating each other, leapfrogging forward through space at the speed of light. The wave sustains itself. It does not need wires. It does not need matter. It just goes. Let me make sure you really see this, because it is the heart of how light propagates. Imagine a region of space where there is a varying electric field. The electric field points in one direction, gets stronger, then weaker, then reverses, oscillating like a sine wave. Maxwell's equations tell us that wherever you have a changing electric field, a magnetic field appears curling around the electric field. So now we have both, but the magnetic field is also changing, oscillating, and wherever you have a changing magnetic field, an electric field appears. This is not circular reasoning. It is a chain reaction. The electric field at point A creates a magnetic field nearby. That magnetic field creates an electric field a little further away. That electric field creates another magnetic field even further, and so on. The disturbance propagates outward. Each part of the wave creates the next part. The wave carries itself forward. No medium is needed, no ether. For centuries, physicists assumed there had to be something for light to wave in, some substance filling space, called the ether or luminiferous ether. Experiments prove there is no such substance. Light waves in, well, nothing. Or rather, light waves in the electromagnetic field, and the electromagnetic field is not made of anything more fundamental. It is itself the fundamental thing. When Maxwell calculated the speed of these waves, he got a number that matched the speed of light. And he realized, in one of the great moments of physics, that light is an electromagnetic wave. That was a unification. Before Maxwell, we had electricity, magnetism, and optics as three separate branches of physics. After Maxwell, they were one. This is the power of physics, to take things that seem different and show that they are the same, to find the hidden unity behind the apparent diversity. The electromagnetic field is one such unity, and understanding it changes how you see everything. Now let me address a question that might be nagging at you. What is the field made of? I said it is not made of atoms. So what is it? The honest answer is we do not know, or rather, the question might not have the kind of answer you want. The field is not made of some substance that you could scoop up and examine. The field is a fundamental aspect of nature. It is one of the basic ingredients of the recipe. Asking what the field is made of is a bit like asking what space is made of, or what time is made of. At some point, you reach the bottom. You reach the primitives. The things that are not explained in terms of other things but are themselves part of the explanation for everything else. In modern physics, in quantum field theory, we understand the electromagnetic field as being capable of existing in different quantum states. The ripples in the field, when you look at them quantum mechanically, come in discrete packets. Those packets are photons. Light is made of photons, but a photon is not a little ball flying through space. A photon is an excitation of the electromagnetic field, a quantum of the field, a unit of disturbance. It is still the field. The field is primary. The particles are what you see when you look at the field with quantum eyes. But I do not want to get too far into quantum mechanics today. That is another lecture entirely. Let me stay with the classical picture for now. The picture of fields as smooth, continuous, spread throughout space. Here is something else wonderful. The electromagnetic field carries energy. It carries momentum. It is not just an abstract mathematical convenience. It is physical. When light shines on you, it pushes you. The pressure is tiny, too small to feel, but it is there. Sunlight pushes on the Earth. Sunlight pushes on asteroids. In fact, there are proposals to make spacecraft that use sails, literal sails, to catch the light from the sun and ride it out into the solar system. Light can push because the electromagnetic field has momentum. Think about how strange this is. Something that has no mass, something that travels at the speed of light, still has momentum and can push on things. In classical physics, momentum is mass times velocity. No mass, no momentum, right? Wrong. Electromagnetic radiation carries momentum even though it has no rest mass. This was a puzzle that Maxwell and others had to work through. The answer lies in the energy of the field. Where there is energy, there is something like mass, thanks to Einstein's famous E=mc². The energy of a beam of light acts like it has a tiny mass, and that gives it momentum. When a photon bounces off a mirror, it transfers momentum to the mirror. The mirror recoils, ever so slightly. We have measured this. We have built devices that can detect the force of a few photons bouncing off a tiny mirror. This radiation pressure is what keeps the tail of a comet pointing away from the sun. The sunlight pushes on the tiny particles of dust. Even though the particles are receding, the pressure of light sculpts the tail, and the energy stored in electromagnetic fields is immense. Think about it. The light from the sun travels 93 million miles, takes 8 minutes, and still has enough energy to warm your face and power photosynthesis. Where was that energy during those 8 minutes? It was in the electromagnetic field, traveling through empty space. Crossing the void, the field carried it. Here is another thing to appreciate. The energy density in an electromagnetic field can be calculated. It depends on the strength of the electric and magnetic fields. Near a lightning bolt, the fields are intense, and so is the energy. Near a radio transmitter, less so. But everywhere there is field, there is energy. The universe is filled with a low hum of electromagnetic energy, leftover radiation from the Big Bang, what we call the cosmic microwave background. This radiation fills all of space. It is about 2.7 degrees above absolute zero, everywhere, all the time. The universe glows, not brightly enough to see, but detectably. That glow is the electromagnetic field, carrying the echo of the birth of the cosmos. Let me tell you about something I find deeply beautiful. The electromagnetic interaction conserves charge. If you have a certain amount of electric charge, it does not disappear. You cannot create charge from nothing. You cannot destroy it. You can only move it around. This is a conservation law, like the conservation of energy or momentum, and it turns out to be deeply connected to the mathematics of the field. There is a theorem in physics, called Noether's theorem, that says whenever you have a symmetry in the laws of nature, you get a conservation law. The conservation of charge comes from a symmetry in the electromagnetic field. The equations do not change if you shift the 0 point of the electric potential. That symmetry gives you charge conservation. The mathematics and the physics are intertwined in the most intimate way. Now, I have been talking about the classical electromagnetic field, the one described by Maxwell's equations. But let me give you a glimpse of what happens when you add quantum mechanics. I mentioned photons. In quantum electrodynamics, the full quantum theory of electromagnetism, the interaction between charged particles is mediated by the exchange of photons. When two electrons repel each other, You can picture them as tossing photons back and forth, like two people on ice skates throwing basketballs between them. Each throw pushes the thrower backward. The accumulated effect is a repulsion. This is a metaphor, of course. The real story is mathematical, but the picture gives you a sense of how forces work in quantum field theory. There is no mysterious action at a distance. There is a field. There are particles. The particles interact by exchanging quanta of the field. And everything is local. Everything happens through the field. Quantum electrodynamics is the most precisely tested theory in all of physics. We can calculate certain numbers, like the magnetic moment of the electron, to 12 decimal places, and the experiments agree to 12 decimal places. That is like predicting the distance from New York to Los Angeles to within the width of a human hair. The electromagnetic field, the same field that was known to the ancients through amber and lodestones, the same field that Maxwell wrote down, is understood at the quantum level to extraordinary precision. Let me return to the big picture now. Why does this matter? Why should you care about the electromagnetic field? First, because you are made of it. The forces that hold your atoms together, the forces that hold your molecules in shape, the forces that let your heart beat and your neurons fire, all of these are electromagnetic. To understand electromagnetism is to understand at a deep level why matter behaves the way it does. Second, because our entire technological civilization runs on it. Electric power, electronics, radio, television, computers, the internet, cell phones, medical imaging. All of these are applications of electromagnetism. Maxwell's equations, written down 150 years ago, are the operating system of the modern world. Third, because electromagnetism is one of the four fundamental forces of nature. Understanding it teaches you how to think about fields, about forces acting through space, about waves and particles, about the deep structure of reality. It is a model for understanding the other forces. The weak force and the strong force, the ones that operate inside the nucleus, are also described by fields. Gravity, according to Einstein, is also a field, the curvature of space-time itself. The pattern that Maxwell discovered, the pattern of a field filling space and mediating interactions, turns out to be universal. Fourth, and this is perhaps the most philosophical point, electromagnetism teaches you that the world is not what it appears to be. We see solid objects, we feel solid surfaces, but at the deepest level there are fields spreading through empty space, interacting in intricate ways, giving rise to everything we experience. The solidity is an illusion, or rather, it is a manifestation of electromagnetic repulsion at very short distances. The colors we see are just different frequencies of electromagnetic waves. The warmth we feel is just electromagnetic energy. The world is made of fields and their interactions, and that is a different way of seeing than we are born with. Let me push this point a little further. We evolved in an environment of medium-sized objects moving at medium speeds. Our senses and our intuitions are adapted to that environment. We feel solid surfaces because that was useful for our ancestors. We see colors because different colors carry different information about food and predators and mates. But we did not evolve to see the electromagnetic field directly. We did not evolve to think about things rippling through empty space at the speed of light. We have to learn that. And when we do, the world opens up. Think about this. Most of the electromagnetic spectrum is invisible to us. Radio waves are passing through you right now, and you cannot feel them. Ultraviolet light from the sun is hitting your skin, and you only notice when you get burned hours later. The world is full of electromagnetic activity that we are completely blind to. We live in a symphony of fields, and we can only hear a few notes. But with our instruments, with our equations, with our understanding, we can extend our senses. A radio telescope can pick up electromagnetic waves from galaxies billions of light years away, waves that left their sources before the Earth existed, and bring them to us here and now. An X-ray machine can look inside your body without cutting you open. A magnetometer can detect the tiny magnetic fields produced by currents in your brain. We have built extensions of our senses that let us see what evolution never equipped us to see. That is the power of physics. That is what understanding the electromagnetic field gives you. There is something almost spiritual about this, if I may use that word. The ancient mystics talked about the interconnectedness of all things. Well, here is a kind of interconnectedness that is real and demonstrable. The electromagnetic field connects every charged particle to every other charged particle. When an electron vibrates on a distant star, that vibration can, in principle, reach you here. The field is the medium of connection. We are all embedded in the same web. We are all, in a sense, in touch with everything else in the universe that has electric charge, which is everything. Let me give you one more thought before I close. Think about this. Right now, electromagnetic waves are passing through your body. Radio waves, television signals, Wi-Fi, cell phone signals. Hundreds, thousands of them, all at once, overlapping, crisscrossing, and you feel nothing. They are invisible, they are intangible, but they are there. The information of 1,000 conversations is passing through you as we speak. We are fish who have just discovered water. We are creatures who have lived our whole lives immersed in the electromagnetic field, bathed in it, made of it, and only recently, only in the last few hundred years, have we begun to understand what it is. That is remarkable. That is humbling. And that is exciting. The electromagnetic field is not just a concept in a physics textbook. It is the invisible scaffolding of reality. It is the web that connects everything to everything else. It is the carrier of light and the enforcer of chemistry. And now you know it is there. So the next time you stick a magnet to your refrigerator, or turn on a light, or feel the warmth of the sun, remember, you are playing with the field. You are disturbing the web. You are participating in the great electromagnetic dance that has been going on since the beginning of the universe. And if you want to go deeper, if you want to really understand the mathematics and the experiments, there is so much more to learn. Maxwell's equations are waiting for you. Quantum electrodynamics is waiting for you. The whole beautiful structure is there, ready to be explored. Thank you for thinking with me today. Now I have a question for you. What everyday experience would you most like explained in terms of the electromagnetic field? Write it down. Think about it. I would love to hear what puzzles you most.